Hi there! By the end of this video, you will have written your first program in VEX without any hassle. With this code, you will get a ripple effect. You will see the result applied first on a grid, and then also on a sphere. First of all, VEX is a programming language inside Houdini. VEX can be used in different contexts. You can use it in rendering, compositing, modeling, and motion effects. In this video, we are going to use it for modeling. In the object context, at the geometry level, VEX allows you to directly set, modify, and update attributes on points, primitives, vertices, and entire geometry. You must be thinking, why bother learning a computer language? I want to be an artist, not a programmer. I don't want to waste my time writing many lines of code. Well, the main reasons why you should bother learning VEX are time and power. VEX will save you a lot of time by executing instructions faster and efficiently. VEX will also give you the power to create customized tools to achieve unique results. And good news, to achieve results using VEX, most of the time you will only need to write a few lines of code. Now, how to start using VEX? What should I know first? Many people relate programming with advanced mathematics, physics, and computer science. And they are correct. If you want to write an advanced and sophisticated program, you need that knowledge. But we don't need that. As mentioned before, in Houdini, to achieve results using VEX, most of the time you only need to write a few lines of code. After all, VEX is a language, so by learning basic syntax and a couple of instructions, you will be ready to start using this language to communicate and interact with Houdini. If you watched episode 04 of this section, Attributes, then you already have the main knowledge to start using VEX. Let's remember the main concepts and let's also add some new ones. The main data types are float data, composed of decimal, positive and negative numbers. Integer data, composed of integer, positive and negative numbers. Vector data, or three-dimensional data. Each element is composed of 3 floats. And string data, this is treated as text and can contain characters and numbers. We also know that the geometry components are points, vertices, and primitives. And attributes are name values stored on geometry or its components. So you can store values on points, vertices, primitives, or the entire geometry. But you don't always need to store all the data on the geometry components, as this will consume your computer resources. Sometimes you will only need to store values temporarily on memory. For this purpose, instead of defining attributes, you only need to define variables. Variables are named values stored temporarily on memory. Now, to use your data, either attributes or variables, you need to declare it first. For attributes, you type the initial of the data type, then the @ sign, and finally a name. For variables, you type the data type and then a name. By the way, predefined attributes, as they already exist, they don't need to be declared. For instance, position attribute P can be used directly. Another concept to know about is vector. By definition, a vector is just magnitude and direction, and the most common vector used in all 3D applications is point position. Let's visualize vectors in Houdini. Divide the left pane using the option Split Pane Left-Right. Change the pane tab type to Geometry Spreadsheet. In the viewport, press D and go to the Background tab and change the color to dark. In the network editor, create an empty geometry and rename it as VEX. Double-click to dive inside. To create a point, use the Add tool. Press Tab and start typing add. Press Enter twice to place the node. Enable the checkbox to create a point. A point is created and you can see a tiny small dot in the center of the scene. To see it better, activate the Display Points option. And you can also activate the Display Point Numbers option. In the geometry spreadsheet, we can see we have the point 0. It has only the attribute P defined by its 3 components or coordinates x, y, and z. Change the position for point 0. To visualize the position attribute as a vector, select the Add node and press X. Press L to lay out the nodes and H to home all the nodes. A Visualize node is added. Select it and go to the Visualizers tab. Change the type to Marker and the style to Vector Trail. Now we can see our position as a vector in 3D space. You can see a vector has a length or magnitude and it also has a direction. You usually define a vector not using the magnitude and direction but using its x, y, and z components. Create a box. Connect it to the Visualize node and press W to toggle to wireframe mode. The box has 8 points and each point is represented as a vector. In the geometry spreadsheet, you can see the list of points and the attribute P components, Px, Py, and Pz. Okay, we already know what a vector is and how it's defined. Let's continue and start with VEX. You can use VEX in 2 ways. Directly using wrangle nodes. In these nodes, you can directly type VEX code. Indirectly using bob nodes. Inside these nodes, you don't need to type VEX code. Instead, you use a graphic interface to lay out the instructions. Then Houdini in the background creates the VEX code. In this video, we are going to create VEX code directly using wrangle nodes. Add a grid. Set the size to 4 and the rows and columns to 3. Connect the output port of the grid to the Visualize node. We have a grid with 9 points and each point has the vector attribute P. As P is a vector, so it is defined by its 3 components x, y, and z. Let's add a wrangle node. Click and drag on the output port of the grid node. Press Tab and start typing wrangle. You can choose between the point, vertex, or primitive wrangle, depending on which component you want to work on. Or you can choose the attribute wrangle, which is a general version. Select the attribute wrangle and press Enter. Change the display flag to the attribute wrangle. Select the left side nodes and press Delete. We don't need them anymore. Select the wrangle node. By default, this node is set to run over points, but you can set it to the geometry component that you need. I've made this little guide to help us to write our first program. As you can see, writing code usually consists of 2 steps. The first step is to define your custom attributes or variables in case you need them. And the second step is to process the attributes and variables. Remember, you can use custom attributes when you want to store the values on the geometry components. But for temporal calculations, you can use variables instead. Variables are not stored on the geometry, but in memory only. To declare attributes and variables, use the help guide as a reference. Remember to always end an instruction with a semicolon, and to add a comment, start a line with a double slash. Comments are just informative and won't be processed. Before start typing code, it's always a good practice to use command lines to describe in simple words what you want to achieve. At the moment, we are only practicing, but anyway, we have 2 steps to do. Let's type 2 command lines. First step, declare. Second step, process. In the declare section, let's create an integer point attribute. Type I, then the @ sign, a name, and end the line with a semicolon. For the change to be effective, you have to click outside the VEX code. Now you can see the created attribute myValue is displayed in the geometry spreadsheet and it has assigned 0 as a default value, but you can define your own value. In the declaration line, add equals 5 and click outside the code. Now all the points have a value of 5 for this attribute. To process this attribute, just type it and use math operations or functions. For example, let's add 2. Just type @ myValue equals @ myValue plus 2 and semicolon. With this expression, we are adding 2 to the original value. Click outside the code. As expected, the attribute value has been updated to 7. Let's modify the position attribute P. As position is a predefined attribute, you don't need to define it. You can process it directly. Let's modify the Y component. To access the Y component, type @p.y equals @p.y plus 1 and semicolon. With this expression, we are adding 1 to the original Y value for the points. Now, the Y value for each point has been updated to 1. Now, let's create a float variable. Type float myConst equals 1.0 and semicolon. Nothing has changed. Let's use this variable in the code. In the last instruction, replace the value 1 for myConst. Nothing has changed. Now, change the assigned value for myConst to 1.2. The Y position has been updated and all the points have been moved to 1.2 in the Y direction. Let's do something more interesting. Let's do a ripple effect on this grid. Duplicate the wrangle node by holding Alt and dragging the node. And delete the code. In the viewport, press W to toggle to Smooth Shaded and check the Display Points and Display Point Numbers options and change the shading to Smooth Wire Shaded. Now select the grid node and increase the rows and columns to 60. Select the wrangle node and rename it as Ripple Effect. In the code box, press Alt-E. Now we have more room to work in. Delete all the lines to start from scratch. As mentioned before, to start, it's a good practice to use command lines to describe the process using simple words. We want to achieve a ripple effect. First, we will need to declare attributes and variables. And second, we will process the attributes and variables. To get the ripple effect, we will need to specify the location or center of the ripple effect. Now, each point in the grid should be moved in the Y direction depending on how far is from the ripple center. So, we need to find the distance between the grid points and the ripple center. With this calculated distance, we can modify the Y position according to the distance to the ripple center. Now that we have a clear idea about the procedure, it's time to convert it into VEX code. Let's start by defining the ripple center. This center is a position, so we can define it as a vector variable. Using our help guide below, to declare a vector variable, we just simply type vector and then the name, center in this case, and end the sentence with a semicolon. To be more descriptive, rename the variable as ripple center. The variable has been declared. Let's assign an explicit value. To assign values to a vector, as it has 3 components, you have to put the 3 values separated by a comma inside curly brackets. Before finding the distance between the grid points and the ripple center, we have to declare it first. Let's do it. As this will be a decimal number, we have to declare it as a float variable. Type float a name, dist in this case, and end the line with a semicolon. To calculate the distance, we can use a function called distance. How to use it? Just press F1 to get help with this function. You can see this function gives us the distance between 2 points or vectors, and we need to list the 2 vectors inside the round brackets. So the first point is each point in the grid. For this you type the @ sign and P, and the second point is the ripple center. Now, how to modify the Y position? As a first try, just add the distance to each point. So let's type our new Y position @ P.Y will be equal to our original Y position @ P.Y plus our variable dist, and the line with a semicolon. Click on the Apply button to update our VEX code. The code is updated and you can see the effect on the grid. Every point has been displaced in the Y direction according to its distance to the ripple center. The furthest points have the longest displacement, while the closest points have the shortest displacement. Click on the Accept button to close the coding window, and minimize the Network Editor pane and the Geometry Spreadsheet pane. At the moment, the Y displacement is directly proportional to the distance between each point and the ripple center. Instead of a linear variation, we require a wavy variation. From school math, we can remember that the trigonometric functions sine or cosine can provide that wavy variation. Let's use the cosine function. Type cos and put the dist variable inside round brackets. Click outside. Okay, we have something. That wave looks too big. Let's modify the distance. Multiply it by 2. Try 3. Now 5. A wavy pattern starts to appear, although the height or amplitude is too high. To reduce the amplitude, multiply the result by 0.5. Let's try 0.2. Okay, it's better. Now let's add something to the distance. Add 0.5. Now try 0.8. You can see it has the effect of moving or offsetting the wave. We have a ripple effect. Nice. But changing the data inside the code is difficult. To have a more useful tool, instead of having hard numbers in the code, let's define them as variables and then convert them into parameters or channels. The first variable will be the frequency. Type float freq and assign a value of 5. The second variable will be the offset. Type float offset and assign a value of 0.8. And finally, the third variable will be the amplitude. Type float amp and assign a value of 0.2. Now replace the hard numbers with the variables. Click outside and nothing has changed. If we change a variable value, the graphic will be updated. Okay, our code now is more readable, but we still have the problem of updating values inside the code. To solve this issue, we need to create custom parameters. Let's bring our help guide on how to create channels. So, we need float channels as our variables are floats. Replace the assigned values with channel expressions following our help guide. You have to place the channel names inside single quotes and inside round brackets. Type CHF frequency for the first value, CHF offset for the second value, and CHF amplitude for the third value. Now click on the Create Parameters button on the right. Houdini creates the channels in the interface, and now you can use them and change them and even animate them as any other parameter in Houdini. But the values were set to 0. Let's update to the last values we used. 6 for the frequency, 0.8 for the offset, and 0.2 for the amplitude. Our ripple center can also be used as a parameter in the interface. As this is a vector, we have to type CHB, ripple center. Click again on the Create Parameters button on the right. The channel ripple center has been added, and now we can modify the ripple center using the interface. Restore the network editor pane. Select the grid and increase the rows and columns to 200. Select again the wrangle node and minimize the network editor. Increase the frequency to 8 and decrease the amplitude to 0.15. Let's animate the offset using an expression. We could use the frames using $F or the time using $T. Type $T. Play the animation. Too fast. Activate the real-time toggle and play again. The offset speed is rather slow. Multiply $T by 2 to double the speed. Play the animation. Better, although the ripple direction should be the opposite way. Type a minus sign in the expression to invert the values. Play the animation. Okay, we have the ripple effect on the grid, but it would be better if the waves fade out with the distance. How to do that? Well, we need to multiply the Y position by a value that decreases with the distance from the ripple center. At the moment, the variable dist ranges from 0 at the center to 2 on the sides. We need a variable that starts with 1 at the center and with a value less than 1 on the sides. So, we need to remap our dist variable from a range that goes from 0 to 2 to a range that goes from 1 to 0.5. Let's create a new float variable and call it Decay. In the process section, type decay equals. Now, to remap a range, we need a function called fit. Type fit and round brackets and end the line with a semicolon. On the word fit, press F1 to get help about this function. As you can see, this function takes a value in one range and shifts it to a new range. We need to specify the value to be remapped, the original range, and the new range. And that's what we need. Close the help window. So, the value to be remapped is the variable dist. The original range is from 0 to 2, and the new range is from 1 to 0.5. Okay, now we need to multiply the Y position by this value. The new Y position will be the last calculated Y position multiplied by the decayed variable. Click outside the code, and it works. Play the animation. It also works fine. Increase the amplitude to 0.18 and reduce the last value for the new range from 0.5 to 0.3 to have a greater reduction of the amplitude with the distance. Play the animation. Increase the offset speed a little. Change the factor from 2 to 2.4. Play the animation. It's better. Now, let's apply this effect on a different geometry. Restore the network editor. Create a sphere. Change the primitive type to polygon mesh, the radius to 2, and the rows and columns to 120. Connect the output port of the sphere to the ripple effect node. In the code, let's disable the decay line by placing a double slash at the beginning. Now, let's move the Y position of the ripple center parameter. Okay, now we have ripples on the sphere. Select the sphere and increase the rows and columns to 200. Select the wrangle node again. Let's animate the Y value for the ripple center. At frame 1, alt-click to set a key with a value of 0. At frame 60, alt-click to set a key with a value of 5. At frame 120, alt-click to set a key with a value of 0. At frame 180, alt-click to set a key with a value of -5. And at frame 240, alt-click to set a key with a value of 0. Play the animation. Maybe too fast. Let's increase our animation range. Click on the Global Animation button, change the end frame to 480. Click on Apply and then on the Close button. Go to the Animation Editor tab. To decrease the speed, just duplicate the source frame for each keyframe. This will give us a slower speed for the movement of the Y position of the ripple center. Go back to the scene view and play the animation. It's better. Change the shading mode to smooth shaded. Okay, you have successfully written your first program in Houdini to make a simple but interesting ripple effect. This concludes this video, and with this episode we are also concluding section 02, Understanding Houdini. Stay tuned for section 03, Quick Start in Houdini. This will have a project-based approach. We'll be covering all the processes to produce the final shot, mainly modeling, texturing, lighting, and rendering. I'm starting to plan the content for this section, and I hope to release the first episode in about 3 or 4 weeks. Until then, keep practicing what you have learned so far, and keep looking for tutorials to increase your knowledge in Houdini. Thank you for watching this video. I'll see you soon in the next section.